I did majors in physics and applied maths.
Oh shit.
So not what I'm doing now, but what I was interested in. I was interested in how everything worked and just maths in general. Like I like maths. Physics for me was like explaining how the world works. Obviously other sciences do as well. I was always interested in other sciences, but that's what I wanted to do, and then I love music. So I just studied what I liked best through university instead of like what would give me a job or
Yeah.
something.
Yeah, I like that. Yeah, I was always fascinated with physics, but maths wasn't a strong suit.
Yeah.
So, but I geek out on like physics documentaries. I'm reading a book. Have you read The Greatest Story Ever Told by Lawrence Krauss?
No, I haven't read that one.
Oh, dude, it is the
Oh, okay.
shit. It's so good. But yeah, I always lacked the maths, and I think that kind of stopped me from getting into physics. But you did,
It's very maths
yeah, it's
heavy.
very
Yeah.
maths heavy, man. You gotta like, because the language of the universe is maths.
Yeah.
You
Yeah.
know, so if you're going to describe nature, the most precise and accurate way you can do it is
Yeah.
through mathematics. It's not through words.
Yeah. And in my physics degree, we would use maths that we would learn following year or semester in my applied maths major. It's like we hadn't like we just you just use it in physics, and then like what is this math? And then you learn it later in maths if you're doing maths. So
Right.
like
Oh, that's cool. So, in high school, did you do? Obviously, you must have done physics.
yeah,
Yeah, and
I did physics, maths. I did the old course. Well, not old, but like the courses now. I did the ones before that. So
how
I
long?
didn't do like maths what 2A to whatever, like calculus and the other thing. I don't know. Basically, it's like two. It's cool, like two maths, two science.
Yeah.
So like physics, chemistry, maths, and hard maths. And then I did English literature and music
Okay.
because I was arty or whatever as
Yeah.
well.
No, that's cool. You have a nice balance between art and science.
That's the idea.
Yeah. So, how did you finish your bachelor's in science slash music?
Yeah.
How did you decide to do what you wanted to do next? Like, did you have a direction already? Did you have a goal in
Kind
mind?
of. I had a goal. Like my research I'm doing now, I kind of started that during high school as like a hobby, kind of like just in self-interest.
Hmm.
Like, because I would, look up maths things before that. And I do maths outside of school because I was that sort of guy.
Such a nerd. Dude. No one talks
Maths.
like this, man.
I would at the playground in primary school. I would I would go through like just multiplying things by two, like just like doubling. I'd just see how far I could double things,
Right.
or like I'd do times tables and like power tables, like instead of playing
Oh
with
my
kids.
god.
So I always liked maths. And what are we talking about again?
No,
I'm
man.
just getting
That was beautiful.
memories
No.
of my
But,
days.
dude, I love it. It seems like you're just a nerd.
I was just a nerd. I want to answer the question though.
Oh, you started that. You had this interest, this hobby ever since high school.
All right, yeah, my research now. Yeah, how did I get from there? Yeah, do I have a goal? Okay, yeah. So, and then I kind of learnt that like you can, then I fell in love with music, after science actually, and then that just got in the way. I couldn't do
Really?
anything else. But then I found out that you can describe music using maths, and I was like, oh, this is the shit. Like. It's like because I hear it and I play. I love music, but then I can like nerd out on the maths of it.
Right.
And so like in year 9, like we got taught about like the harmonic series in our music class,
Uh-huh.
and I was like, oh, that's numbers. Like I can. This is awesome. I didn't know that. And so from then I just read all the Wikipedia articles, and then I discovered all of this speculative music theory, mathematical music theory, and microtonal music, and that sort of weird stuff, like weird music theory stuff, within the next year. And then I've just started working at that throughout, just distracting me from my actual studies.
Mm.
And then getting to the end of my bachelor's, I was like, I need to just study this. Like, I can't do anything else.
Right.
Like, I'm hardly getting through all my units. Like, I'm not doing that well in my physics and maths majors anymore because I want to do it, but I'm just spending all of my time doing this thing. And once I'd finished my music degree, I still hadn't finished my science and maths degrees, and I wasn't getting enough practice done. And then I thought, you know what, I don't want to do a recital because I won't do that well. I'm going to write an honours dissertation, which not many people did.
Mm.
People did as recital and then wrote a little bit,
Mm.
but there was an option to do musicology instead of music. And I was like, no, I'm going to write about this stuff that I've been thinking about for the last, by that stage, 8 years.
Right.
8 years? Yeah, 8 years.
Right.
And then that led to the PhD ultimately.
Right. Before we get into that, so you mentioned how math is intertwined with music. Can you
Yeah.
just elaborate on that?
Yeah, love to, sure.
Yeah.
I mean, well, firstly, like maths, you described before, maths is the language of the universe. Like, maths, itself isn't a science, but it's what we can use to, at the core level, describe how everything works. So that applies to music. Music, like the stuff I'm studying, it's kind of like maths that I can hear. So like, I play with the numbers and then I directly like hear the result, which is awesome. So the way that works, I mean, any musical instrument or any musical sound you're hearing, it's an object that's vibrating at a particular frequency, and then you get the rarefactions and the other things. It's been a while since I've done physics. I know what they're called, but I forgot. In the the airwaves, and then your inner ear kind of picks that up, and then it resolves the different frequencies, and then your brain interprets it. And so that's all numbers. And then like one thing I'm really interested in is in like if you're playing an instrument, you do scales practice and you learn your theory, but that's all maths as well. Like chords are maths. Like chords are different frequency ratios that have a special relationship to each other, and it's all related to the harmonic series, which is like, and when an object vibrates at its like fundamental frequency, then half of the object also vibrates, and then a third of the object also vibrates, and you get a note that's a certain interval above that and a certain interval above that. You make that to build chords. You make scales that get those chords, and then eventually, some other maths happens and you get led to like the keyboard. And then I'd look at the keyboard and be like, why are there 12 notes? Why are 7 of them white? Why are 5 of them black? Everyone else kind of just accepted that was what music was. But that's defined by a particular optimization of mathematical and physical sort of things optimized by mathematical processes.
Right. Can you just explain what a harmonic series is? Because for the people who don't have like a music background, it can be a little tricky.
Yeah, I'll go over that again. So so physically, object vibrates. The whole object vibrates. Right. Half the object vibrates. A third, a quarter.
So if you give like an example of it on a keyboard or even a guitar string.
Yeah, so a guitar string's probably a good one. So the whole string. Yeah, so you pluck a guitar string. That's probably like the lowest string on the guitar, and you pluck it. And then if you put your finger halfway, then you stop the whole string vibrating. And then you make the only the half string vibrate, which was going to happen anyway. If you touch it lightly, that's when you're playing harmonics on a guitar.
Okay.
And if you go like do do, it doubles the frequency.
Okay.
You hear that as kind of the same note because it's a really simple ratio. So that's the first harmonic. And then after that, if you lightly touch the string 1/3 of the way, then you're stopping it because it's an antinode in the whole string. As in the whole string is moving at that bit, you're stopping it from moving by putting your finger there. You're stopping half of it moving by putting your finger at this bit that isn't like the end of it, but you're at an antinode for 1/3 because it's like it stops vibrating there, and you get like the do 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 do, and then you go up this thing that's called the harmonic series, basically because it's like a whole number of multiples of the ratio something's vibrating, which are directly related to fractions of the length of the object or the length of the string that's vibrating.
So these notes, so you have a fundamental note, but that fundamental note has all the other notes of the harmonic into it, right?
So yeah, you're asking all the right questions because you know when I'm skipping things. That's good. So all of these notes are in, like, they all happen. Like the object vibrates, half the object vibrates, but you can isolate them by, like I said, by kind of stopping things. But yeah, like, so the sound of an instrument is, you can have two instruments playing the same note, but they sound different because you have different amplitudes of those different harmonics in the sound. So like every object, like parts of it also vibrate when the whole thing does at different like amplitudes depending on what the object is. And
so when you play a guitar and you ring a string, there's certain parts of that harmonic are more accentuated. They are more obvious than other parts. And if you
Yeah.
if you go like halfway on the string and you pluck it there lightly, then that note specifically shines more than the others in
Well, yeah, you effectively mute
the rest.
the other ones from
Okay.
from happening by because you're literally stopping the string, because if you touch the string, you stop it from vibrating at that point.
Right.
But you're not pressing it down so that you're making like you're changing the length of the string.
Right.
But yeah, so it's basically that. But then you can do a similar thing like with your voice. Like everyone sounds different.
Uh-huh.
They have their own voices because of the way their vocal tract is shaped.
Right.
And then the way we speak with different vowels is that we move our vocal tract and whatever, so we resonate at these different harmonics that are based off of our fundamental tone.
Okay.
Otherwise, everyone would just sound like a robot, and everyone would sound the same, and you wouldn't be able to speak.
Yeah.
It's like you change the thing that it's vibrating in so that you resonate different like harmonics of the actual sound. So I've confused that a little bit, unfortunately. Sorry, because I've added in the object that's vibrating in and resonance. Your vocal cords do the same thing every time. So it's like if you put a guitar in a different room, it's going to sound different
Right.
as well.